Now we're going to talk a little bit more specifically on how a magnetic field looks around a magnet. And most of the time we're going to use a bar magnet because that's a convenient shape to be using. The magnetic field is like any other field. It is a vector quantity. It has a magnitude and a direction. And the magnetic field is given the symbol B, basically because they said the electric field in some paper way back when was A, and the magnetic field is B. So the magnetic field is B because nobody ever bothered to rename it with everything else, and we have a lot of M's that we use already. So the magnetic field is also called the B field. The direction is given by the direction of the north pole of a compass will point. So the north pole of a compass points at the south pole of a bar magnet because opposites attract. And magnetic field lines can be used to show how these field lines, traced out by a compass, might look. And a lot of the rules that hold for the electric field lines hold for magnetic field lines, that they can never cross, for instance. So looking at the bar magnet more closely, if we put a bar magnet in a suspension of iron filings, we get those iron filings to line up with the magnetic field. So the direction the field is towards the North Pole. So always towards the North Pole, always towards the South Pole. So here we have it facing towards the South Pole, here's towards the South Pole. Here is away from the North Pole, presumably towards a South Pole. Now, the magnetic field between two opposite poles is going to look very similar to that of individual bar magnets. So you can think of an individual bar magnet being in here, where basically they look like they're embracing. That we still have the same rules, that we're pointing away from the North Pole and towards the South Pole at all points, because again, the direction of the magnetic field is the direction the North Pole of a compass would point. Now if we look at like poles, they look very much like the electric field lines for two like charges. They look like they are spiders repelling each other. So like poles will repel each other. So here now is your chance, is we want to label A, B, and C and put either a right arrow or a left arrow in each one of those locations. So which direction is the magnetic field pointing on each side of the magnet? Okay, so the magnetic field always points to the south, so B is going to the left and D is going to the left, points away from the North Pole and towards the South Pole. So this is to the right, this is to the right, this is to the left, and this one is to the left, as shown here. And again, here's another picture of a bar magnet with a compass nearby.